Hello guys, so this is a session. Okay, in this session we are going to do a chapter which is from engineering mathematics, and its name is limits. Okay, indeterminate form, or in some universities they called is Lopital. Okay, L hospital, Lopital. Okay, Lopital root limits. Okay, but the names are different, but the content is same. Okay, in all the universities. So we are going to start limits, okay, which is a part of engineering mathematics 1. So if you have not subscribed the channel, please subscribe the channel, okay, so that we can bring more content like this. So before starting, I want to tell that your class 12 things should be strong enough to understand the basic things of this chapter as far as it is concerned, and whenever I feel that I need to give the explanation, okay, of something which is from class 12, okay, or the student will not understand or have might forgotten this concept, I will probably try my best. Okay, so we are going to start with the limits, and I'm going to start, okay, with some basic things which you might have studied. Okay, in this session we are going to just understand the definitions, okay, and do two questions, okay, and that's it. So first let me write the name, okay, limits. Okay, so in this chapter, if I say that a function f of x where limit x tends to 0, okay, its value is 0. Okay, and if I say one more thing, that there is one more function g of x, okay, where limit x tending to 0, okay, x is here also, x is tending to 0 and its value is 0. Now one question many children can have in mind, that how you are getting value 0. Okay, we are assuming that we have putting here value of x, and we are getting some value x 0, okay, of the function, and till now I have not specified what function it is. Okay, so we are assuming it is some random function which is giving value 0 and substituting x is equals to 0. Now if I consider a scenario like f of x upon g of x, okay, where limit x tends to 0. Now you will say that, sir, if we substitute x value here, and if I substitute x value in g of x and f of x respectively, you have just mentioned that they give value 0 and this will also give value 0. So you are getting some form of 0 by 0, okay, which we call indeterminate form. Okay, so in this whole chapter we are going to study how to tackle indeterminate form using L'Hopital's rule. Okay, many children say L hospital, but it is wrong, it is L'Hopital's rule. Okay, so what is indeterminate form? The indeterminate form is that it means a function whose value on substituting you get something which is not fixed, okay, but you can get its answer by doing some, okay, by doing some conversion, okay, conversion, so that it gets converted into determinant form, which is nothing but that when you substitute x value, you don't get this form, you get some constant thing, okay, which will be your answer. So our whole aim will be using L'Hopital's rule, okay, and converting indeterminate form to determinant form. And how we will know that we have reached determinant form? When we substitute x value and get some constant as our answer. Now what we will study in L'Hopital's rule. Okay, what is actually a L'Hopital's rule, and what will be the process in every problem we will apply. So if I say L, okay, if I say it is L, limit x tends to 0 f of x upon g of x, it is what, 0 by 0. What I will do, find L1. Just listen it out carefully. By L1 what I mean you have to differentiate f of x, you have to differentiate g of x separately. Okay, separately. Listen this word clearly, separately. What does it means? That I will differentiate this f of x, I will differentiate this g of x. What many children do a mistake, that they apply the quotient rule. Quotient rule, that is g dash, okay, g of x the whole square upon gx into f dash x minus g, okay, g dash x into f of x, which is completely wrong. I have clearly mentioned it will be f dash x upon g dash x. Okay, if you have not understand, okay, you will understand when the problem appears. Okay, you don't need to worry much for the timing now. Just remember what I am telling. It means separate differentiation of this f of x and separate differentiation of this g of x. Now if I find L1, okay, which is nothing but limit extends to 0 where f dash x upon g dash x. Now if L1 is what, is some finite value, okay, some finite value, as I mentioned, I will apply Lopital and then substitute x value and check whether if I get a constant answer or not. If I don't get a constant answer, I will again apply Lopital's rule. So here I will check if L1 is finite, okay, finite. So if it is not finite, okay, if it is finite, then L is equals to L1 will be my answer, whatever constant I get, okay, after substituting x equals to 0 in L1, which is nothing but f dash x upon g dash x. After this, what we will do, we will, if suppose I don't get, okay, some constant number, I still getting this indeterminate form, then what we'll do, I will use, okay, I will find L2, which will be nothing but, okay, x tending to 0 f double differentiation of, okay, f double dash x upon g double dash x. Means you have to differentiate this f dash x and this g dash x separately. Now if L2 is finite, then I will substitute x equals to 0 in that and say my limit answer is L2. Now if again I am still getting this form, I will again apply, okay, what I will find L3, which is limit x tends to 0 f triple dash x upon g triple dash x, and so on. So hope you have understand the complete process, okay, what we are going to do in this chapter. Just indeterminate forms will change, okay, and as per that we will solve the questions. Now some basic formulae which I feel a need that you should, okay, keep in mind if you might have forgotten that, which is limit x tends to 0 sin x by x is equals to 1. Second, limit x tending to 0, tan x by x is equals to 1, and limit x tending to 0, okay, log 1 plus x upon x is equals to 1. So just keep in mind these three formulas, okay, they will be frequently used throughout the whole chapter. Now let's do some questions, okay, then we will continue in the next session. So the first question which we are going to see is this question, okay. The question says limit x tends to 0 x into e power x minus log 1 plus x upon x square. So in engineering entrance exam you should know how to represent your answer, okay. It also plays a crucial role, okay, in getting marks, okay, in your examination, compared to what you have been doing till class 12th, that you never thought of representation of answer, okay. You always focus on getting the answer till class 12th, but from now onwards, since you are in engineering, you have to know how to represent the answer. So first step is write L equals to limit x tending to 0 x e power x minus log 1 plus x upon x square. Then do what? Substitute x value in this to know which form it is, okay. So what we are going to do in this lecture, we are going to study type 1 problems, okay, problems which is 0 by 0 form, okay. All the problems which we are going to encounter are going to be of 0 by 0 form. So here if I substitute this value, I will get 0. E power 0 is nothing but 1 minus log 1 is 0 upon 0, which is nothing but 0 by 0. Now, so it is a indeterminate form. Just write this. Now by L'Hopital's, okay, L'Hopital's rule. If I apply L'Hopital's rule, what I get? L equals to limit extending to 0. Differentiate this f of x and this g of x separately. If I differentiate, I have e power x, okay, plus x e power x minus 1 upon 1 plus x the whole upon 2x. Okay, I differentiate this separately. Now if I substitute in the next step, you have to substitute the value and check whether you are getting L1, okay, whatever it is, L finite or not. The moment I substitute 0, it will be 1, this will be 0, this will be 1, and this will be 0. You are again getting 0 by 0, which is again an indeterminate form, IF. I will call it IF, indeterminate form. Now apply L rule. What you get is you have to differentiate this again. Always keep in mind you will write these things, okay. This will become 1 plus x square. Okay, I'm not going to tell how it is happening, okay. This is class 12 part. After this we will substitute and check whether we are getting it finite or not. 1 plus 1 plus 0 plus 1 upon 2. We are getting something 3 by 2. Okay, so this is our answer. And finally what you will write, okay, I will tell you what to write in the last step to get complete marks is always write this step: x tend to 0, x e power x minus log 1 plus x upon x square, its value is equal to what? 3 by 2. So this is our answer. Always write this step, this will give you marks, okay. So this was one question of 0 by 0 form. Now let's move on to the next question. We can use this page. The next question is this: e power 2x minus 1 plus x the whole square x into log 1 plus x. First step was what we used to write L. Limit x tends to 0, e power 2x 1 plus x the whole square x into log 1 plus x. After this what we are going to do? Substitute the values. 1 minus 1 0, this is nothing but 0 by 0, which is indeterminate form IF. Now what you will do, what we can do is we can do one thing. We can apply L'Hopital's rule, which we are doing. Okay, now one thing I forgot to mention in the previous problem is that any child can have a doubt that he might think that I can do this thing. Okay, let me explain this doubt. In this question, any child can think like that. It can be like this: x e power x square minus log 1 plus x upon x square. Okay, then what he will think, I can write this x square as x into x, and then move the limit x tend to 0, e power x, okay, x will cancel out, limit x tends to 0, log 1 plus x upon x into x. He will think he will get answer. Okay, this will be divided by 0, infinity, and this, when we substitute the value, this will be 1 divided by infinity minus. So again he will get indeterminate form, which will be more trouble, because from 0 by 0 in indeterminate form he is converted to infinity minus infinity determinant, which is more wrong. Okay, always try to move from indeterminate form to determinate form. Okay, never try to do these type of things. When you feel, okay, when you can see that after breaking I am getting simplified things instead of going to again indeterminate form. Okay, like here it happened, when I broke up I got a other indeterminate form, which was infinity minus infinity. Now let's come back to the previous problem, okay, which we were doing, which was this problem. It is indeterminate form. Now we will apply what? Lopital's rule. Lopital's rule, which will give me L equals to limit substitute the value. We are again getting an indeterminate form. What we will do? Apply. Okay. See what we are getting. What we are getting, it will become 4 e power 2x. This will become 2. This will become 1 plus x the whole square upon 1 plus x minus x into 1 plus 1 upon 1 plus x, which if I substitute the value I will get 4 minus 2 upon 0. Okay, 1 upon 1 plus 1 upon 1, giving me finally 2 upon 2, giving me answer as 1. So this is our answer. Okay, and in these two questions we have just applied the simple L'Hospital rule. We have not did any big manipulations. Okay, and this type of questions can be asked in your examination. Thank you. In this session we are going to do this much thing only. In the next session we are going to do some more problems. Till then, take care. See you in the next lecture. Bye.